Oh, closest to that side.
Into the booth.
Okay, they'll be over there.
Yeah.
And am I waiting? What am I waiting for to start?
You ready?
I got 1 minute. 1 minute. Hello, everybody. Hi there. Thanks for joining us today. My name is Andy Munitz. I'm Senior Product Manager for Sony Professional Audio here in North America. And what we're going to be talking about today are a couple of things. We're going to be talking about a little historical retrospective on some of the major technologies that Sony Pro Audio has introduced over the years. And then we're going to, it's pretty good, isn't it? And then we're going to talk in more depth about some of our high-end studio microphones and our latest headphone offerings. So to start out with, I've been with Sony, believe it or not, for 40 years. You can imagine, 1984. I'm an old guy. And I got my first Sony reel-to-reel tape recorder when I was 13 years old, if you can believe that. But one of the real joys I've had in working for Sony all these years is seeing the incredible solutions that our brilliant engineers come up for solving common problems that plague a lot of types of equipment. And they don't give up. They think outside the box, and it's fascinating to see what they come up with. Some people don't realize that the very first product that Sony tried to come out with when they started in early 1950s or late 40s was an electric rice cooker. But thankfully, it failed in prototype form, or we'd be talking, like homewares today at a show. Thankfully, we're not doing that. But instead, what they came up with for a first product was a reel-to-reel tape recorder, a G-type tape recorder. And many people also don't know that the name Sony comes from the Latin word sonus, for sound. Check, 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 check. And the name Sony is Latin word from sonus, the Latin word sonus for sound. Our very first product, as I mentioned, was a reel-to-reel tape recorder. And we introduced this product because we wanted to be able to sell it to schools where musicians could literally record their performances and listen back and do a self-critique. That was kind of important. But if you think about it, a tape recorder, what good is it if it doesn't have an input device? So we had to make our first microphone to support the input of that tape recorder. This is a picture of Sony's very first factory floor. If you can imagine how many factory floors we have today, this was Sony's very first factory floor back in 1950, making these large G-type tape recorders. However, we even made our own tape, our own magnetic tape, and we made our own microphones to go along with it. And there's our very first Walkman, where we tried to put a tape recorder into a portable carrying case. But if you think about it, we did come out with our first microphones in early 1950, and we've been improving on that microphone technology through the years. The legend goes, actually, that one of our very first high-end microphones, the C37, became Frank Sinatra's favorite microphone. If you Wikipedia this, you can see this, but it goes that he was, recording at Capitol Records on Vine Street in Hollywood with a live orchestra and singing into a microphone. And the way I heard it is he kept stopping the takes because he didn't really like the way his voice sounded. So somebody came to him and said, Sony's got a brand new microphone, C37, why don't you try it? And he fell in love with it because it gave him the reality, that sensitivity in a microphone that he wanted. He ended up using it a lot and buying multiples of that C37 to take on the road with him to record, to perform live. We've had many microphones through the years. We have a reissue of an early one called a C38B, and we had the C48, but I think you would agree that the microphone that we are most known for, especially today, is this guy on the end, the C800G. This is a very high-end tube microphone, and we'll go into more detail on it because there is some real incredible technology going into that microphone that makes it what it is. We had many firsts though. If you realize, Sony and Philips were responsible for the introduction of the compact disc and the real introduction of successful digital audio that guy used a lot. Here is a picture of Sony's founder, Akio Morita, presenting the first compact disc to Herbert von Karajan, who was the conductor of the famed Berlin Philharmonic, and showing how incredible digital audio can sound, especially as compared to like a lacquer disc or a record or vinyl and so on and so forth, with all of its clicks and pops. And certainly compact discs were pristine and click-free and all that stuff. But if you think about it, one of the things that was really required from a technical point of view to make digital audio was a way to go from the analog world that we live in into the digital audio world. And so you needed an A to D, or analog to digital converter. And we started making these converters. We originally had something called a PCM 1600, and then a 1610, and then this was the final version, the PCM 1630. That is not only an A to D converter, but it's a D to A converter, because once you've captured your bits, you need to be able to play them back and make sound again, so you have to take the digital stuff and convert it back into analog. So it's an A to D and a D to A. But the question then becomes, where do you store those bits once you have them? And we at Sony were certainly very large in the broadcast world as we are today, and one of the formats that was used very extensively were U-matic tape recorders, 3/4 inch tape recorders, and those were color recorders, 3/4 inch cassettes. But for this application, we defeated the color. We turned it off and turned it into a black and white video recorder. And we would store the digital bit stream, 16-bit, 44.1, onto those U-matic cassettes. And then you would do what was called CD authoring, and then you'd send that final tape out to the pressing plant, where they would punch out thousands of your compact discs and sell them to the public. We followed that up with digital audio tape, DATs, if any of you remember those. And we even had DAT editing systems and DATs with time code and things like that. We also were kind of very intrigued and we involved in the development of the early large-scale digital mixing consoles. I don't know if anybody here remembers, but there was a very famous tape recorder company and mixing console company called MCI. And Sony bought MCI, and the 2-inch 24-track machines and the mixing consoles, but it was all analog. So we decided that we wanted to build a large-scale digital mixing console. And this part is kind of fascinating. Well, it turns out everybody out there has heard of the company Solid State Logic SSL mixing consoles. That was started by a group of 5 engineers that started SSL. And every generation they would make a wider, bigger analog mixing desk, and the modules got deeper and deeper, and it would almost break the back of a mixing engineer during the day. So ergonomically, they were really putting some physical strain on mixing engineers. Besides which, they had to slide back and forth to get to various faders and move in and out of the sweet spot of the monitors and so on and so forth. What they realized was the technology was finally available to create a digital mixing console where you could sit in the middle and you could bring things to you. You could stay in the sweet spot of the mix position, and you could have a dedicated EQ and a dynamic section, a delay section, and all those kind of things. And all 5 of the original engineers that started SSL left SSL, moved across town in Oxford, England, and to start their own company, the Oxford Development Group. They fairly quickly were able to make a presentation to Norio Oga, the president of Sony Corporation, who was a huge music fan, an opera fan, and did some opera singing, I think, as well. And he listened and learned from them for quite a long time, and at the end of their presentation, he said, Sony would like to partner with you and make the Oxford console, bring your dream to reality. And that was the console, the OXF R3, large-scale digital console. It was kind of unique in several ways, but one of the ways simply was its operating system. If you think about a regular PC operating system or Windows, that's not reliable enough to do a large-scale digital mixing console. They wanted to use what's called Unix, which is what drives computers that banks rely on and airlines and all that stuff. So they built a Unix-based mixing console. Lots of inputs, very expensive though. Each one of these consoles was anywhere between $500,000 and $1 million, depending. Different frame sizes, but a lovely, lovely sounding console with groundbreaking converter technology and stuff like that. We sold quite a few of them and they were really, really nice. But then we introduced, a few years after that, the Baby Oxford. And the Baby Oxford was designed by the Oxford boys, had a similar sound, really a lovely sound, but it was only in the $20,000 range, motorized faders and all that kind of stuff. And we sold a lot of those as well. Moving on, we were also smack in the middle of digital multi-track land, where MCI were doing very well with 2-inch multi-tracks and analog tape. Our engineers in Japan developed what is called the DASH format, D-A-S-H, digital audio stationary head. And on a 1/2-inch piece of tape, we started out being able to record 24 tracks of digital audio, and then we upped it and we doubled the density so you could do 48 tracks of digital audio. And these were, by everybody's kind of feeling, these were the finest tape transports ever made. They handled tape unbelievably well. To the right here is a picture of a very famous recording studio that was in New York City called the Hit Factory. They bought many of these 48-track tape machines, and here's 7 of them. Each one of these was, a couple of $100,000. And they bought 3 of the Oxford consoles. And at that point, I was a sales guy, and it was one of the best sales years I'd ever had. But it was an incredible facility. And so they loved that technology. We also, our engineers, realized that reverb is really important. For those of you that know, reverb, many years ago was started out in physical echo chambers and things like that. Then you had plate echoes and things. And then computer power got to be strong enough where you could literally synthesize the sound going through arguably a mathematical space. And so we came out with a model called the DRE 2000, which gained a very nice reputation as a synthesized digital reverb. But our engineers, always thinking of a way to do things better, came up with something really, really unique. This is the DRE S777. This was a convolution-based reverb. It doesn't make up spaces. It allows you to capture the actual acoustics of any real space. Convolution, without going into any detail, allows you to take 2 different parameters and map one against the other. So frequency, we all understand how low frequency, high frequency sound, but you map that against time. And so you can be in any space, a concert hall, a studio, whatever, and you can send out impulse tones and then have the microphones that are hooked up to the system say, oh, well, I got that frequency starting and it lasted this long and so on and so forth. And it would create a perfect acoustical map, a real map of that space. And we would put those on data compact discs so that you could plop in, the famous concert halls of Europe, Cathedral of St. John the Divine. I don't know if anybody remembers a very famous alto sax or soprano sax player, um, uh, Paul Winter. He had the Paul Winter Consort. And it was kind of interesting because one of his famous albums, he went to the Taj Mahal and he played in the Taj Mahal with this crazy 20-second reverb, but he had a favorite hidden canyon in the Grand Canyon. You could only get there by taking a boat ride up the Grand Canyon and hiking for about an hour up into the hidden little canyons, and there was this giant rock formation of like 100 feet high, and he recorded himself playing from the bottom and having the microphones way up, and it was this gorgeous sounding reverb. He invited us to his secret hidden canyon, and we captured that canyon as an impulse response, and you could call it up here, and you could call up the Grand Canyon in this 777. Lovely, lovely reverb. Today, of course, convolution-based reverbs, you can get them for your NLEs, and it's not that big a deal, but it's lovely stuff. We came out with it very, very early on. Back in the world of microphones, we came out with our very first wireless microphones in about 1960. This was one of our first wireless microphones. Ooh, it had a solid state transmitter, and the receiver was tube-based, ooh. But I remember seeing one of the ads for this early wireless microphone that was really kind of quirky, who we were trying to market it to. They said, take it next door to your neighbors. I'm going, what? So the theory is that if you were a housewife maybe with a new baby and you wanted to go visit your neighbor friend next door, but you had your baby sleeping in your house, you could take the transmitter, put it in the baby's room, take the receiver, go next door and hang out with your friend, and you'd be able to hear when your baby started crying and woke up. Quite the marketing plan, but very interesting. We then, though, decided to come out with really very high-end industrial bulletproof broadcast quality wireless. If you think about it, broadcast is a mission critical business. TV stations, they can't crash. They got to be on the air all the time. And so we came up with wireless microphones that could get used for all sorts of things. Racing, cars where you'd put a transmitter inside of a car, giant golf outings, all these things, as well as traditional things. And we came out with this kind of quote unquote bulletproof wireless system. As a matter of fact, in the 80s, we sold some of the most reliable wireless on the market. The Rolling Stones used this, Bruce Springsteen used it, a lot of people used, Michael Jackson used our wireless, because our stuff could be transported from gig to gig, studio, concert to concert, and it would hold up, and you could rely on it when it got there. But we didn't really market it, and we didn't let the world know that we were the wireless system of choice. Anyway, that was our fault. So, what we're going to talk about now is really a very interesting topic if you're into microphones at all. Many of you may know that we make a very well-regarded microphone called a C800G. We introduced this microphone in about 1990. It is a thermoelectrically liquid-cooled tube mic. Liquid-cooled, are you kidding me? Nobody knows that, but we'll talk about that in a second. It's designed for critical recordings because obviously we had these digital multi-tracks and digital mixing consoles, but if you don't have an incredible microphone at the very front of the chain, you're making it up. It's not the real deal. So we worked very hard in creating this microphone. It uses a large gold evaporated diaphragm, but what our engineers found out immediately when they first decided they wanted to build a tube microphone, they first went and bought all the other tube microphones that were already on the market, and they tested them. And they found out like immediately that they spec'd differently day to day. Why? It had a lot to do with the temperature of the tube and the temperature of the studio they were in. And the difference in temperature of the tube has a lot to do with the noise floor of the microphone and the sonic characteristics of that microphone. Well, if there's one thing a Sony engineer really hates is not having a Sony product that performs perfectly every time you use it, regardless of where you use it. So they realized after testing that our microphone if you kept the tube at exactly 13 degrees Celsius, the mic had its best spec, lowest noise, best sound. But how do you keep the temperature of a hot glowing tube at a certain temperature? You can't blow an air conditioner on it, and you can't dunk it in a bucket of water. So what they came up with is they found a semiconductor device in 1990 called a Peltier device, Peltir, which is a semiconductor where one side gets hot, like you figure it would, but the other side literally gets cold. And they now use them in car refrigerators and cooling computer towers. And we take that tube and we lay it next to the cold side of that chip with some thermal grease in between to kind of like help, transmit the temperature. And we regulate the temperature of the tube to stay constantly at 13 degrees Celsius. The microphone is cardioid and an omnidirectional position, but the other thing, from a purely mechanical point of view, that our engineers learned is that a microphone's job is to take, obviously, sound, pressure, waves in the air, and through the use of a diaphragm, turn that into electrical impulses to get recorded. But if you think about it, those sound waves also will hit the body of the microphone and cause the body of the microphone to vibrate subtly. And if that vibration subsequently also makes its way up into the diaphragm, that can muddy up the sound, which is not a good thing. So our engineers decided, let's make the body of the C800G out of two different types of metal, one on the bottom, one on the top, because different metals have different resonant frequencies. And at that transition point between the two different metals, they don't transmit their vibrations one to the other. This is how kind of, off our engineers go to solve problems. I think it's great. Now, the C800G, for those of you in the know, we were out of production for a couple of years. We started running out of the tubes that we had originally purchased from Eastern Europe and Russia, where they still had tube factories, and we bought a whole bunch, and we started running out of those tubes because every couple of years or whatever, a tube microphone may need to be retubed. And so, the idea is, we'll just discontinue the microphone, and I didn't particularly think that was such a great idea. So we kind of mounted a concerted effort and a search to find replacement tubes. I originally found like 900 military grade tubes that had been built for the US military, and I took a representative sample of them and sent them to Japan, to the factory, and they tested them and they say, sorry, they don't meet spec, they're not quiet enough for use in our microphone. I figured we were dead. So I was walking around the New York AES show, 4 or 5 years ago, and I came across what was the History of Audio Recording Museum in New York City. A little old man in a rumpled suit sitting next to a giant equipment rack with big old knobs on it. And I go, this guy knows about tubes. So I said, any place I can still get new tubes made these days? And he goes, go over a couple of aisles, there's a little booth that's making tubes. I go and introduce myself, and I say I need tubes for a C800G. He says, oh, you need a 6A U6A tube. He knew everything about it. It's a pentode, blah, blah, blah. The guy is he's a tube genius, and he manufactures tubes. So he said, I'll make you brand new tubes. They'll be better than the ones you originally had. But it was taking too long as he was building a new factory. He finally said, just send me one of your tubes, and I will send it to one of my partners, compatriots, who lives still in Eastern Europe. He sent it over. The guy goes, oh yeah, I know this exact tube. I know the factory it was made in. It's not there anymore, but I know where there's a big stash of the original tubes. So we got all those tubes, sent them back, bought the exact same test gear that we use at the factory, and this guy in the US has culled through all of these tubes, and we are now only using tubes that surpass the original noise spec that we had back in the original production runs. So we are using the exact same tubes from the original factory, and we're back in production. So that's a great thing. Now, I'm kind of boasting a bit, I admit, but I've heard from so many people that the C800G is considered one of the two finest microphones in the world. It has a retail price of about $10,700, and because of the demand of them by a lot of hip hop and R&B artists, We are about 2.5 years back ordered at this point. You just can't get these things, which is kind of crazy. Um, the characteristic that people love about the C800G mic is something called a vocal forward voicing. What that really means is that when you record your vocal with a C800G and you bring it up and you bring all the other elements in your mix up around it, your vocal still sits out in front. It's very up front, and you don't have to run your vocal through a lot of plugins to try to get it to do it. The microphone kind of does it for you. And that's what people, one of the things they really love about it. Now, the Peltier cooling system, I kind of told you about this semiconductor device that sits in here, and the tube is in here as well. And if you come over, we've got one of the microphones over there, but if you put your one finger on top of this housing and one finger below, the top is slightly warm and the bottom is cold. And that's the cooling device. Now that's nuts in itself because we, again, regulate the temperature. But check this out. We still have to get rid of that heat. So we have this heat sink mechanism here. But the heat is not going to go from the tube area by conduction out to the heat fins. There's actually a liquid transfer mechanism to do it. And how we do it, it's not a pump, but this is how we do it. There's a hollow pipe that goes from here all the way out to the heat sink. And that hollow closed end pipe is filled with a specially chosen fluid whose boiling point is at the temperature of the hot glowing tube. Because what happens when we boil a fluid? It turns into a gas, water and steam. So now we create hot gas bubbles right around the tube, and those hot gas bubbles float out to the end of the heat sink where they release their heat to the fins, condense back into a liquid form, dribble back down to the tube area, and go round and around all day long. Kind of cool. But what's important is that when you use the microphone and you mount it on a stand, you want to make sure that the orientation of the mic is perfectly horizontal heat sink. Whether the mic is inverted or not doesn't matter as long as the heat sink is horizontal. But even a little bit better is to give it a couple of degrees of elevation so the gas bubbles float up to the end. If you ever see anybody using this mic with a heat sink aimed down, not a good idea. You won't get the right usage, the right sound, and the tube may even not have as long a life as a result. So this is how our engineers think. They come up with incredible off-the-wall ideas for solving these problems. Now, back in 2015 or so, at the highest level of Sony Corporation, we decided that we wanted to differentiate ourselves from all of the other big electronics companies that did audio and did, like hi-fi gear or whatever, by promoting the concept of high-resolution music. The idea simply being that if you create music, you capture music in high res, you play it back in high res, you can touch the emotion of the listener far more deeply than if you just listen to a bunch of MP3s in your pocket. Don't get me wrong, 1,000 songs in your pocket is incredible, but a little bit of that emotion gets shaved off. So we decided to make a whole series of high-res audio components. And of course we had amps that went out to 50K, and we had speakers with super tweeters and all this kind of stuff. But guess what was missing? The very front of the production chain. Because if you fake it there, all the rest of this other stuff just doesn't matter. So we needed high-res microphones. And we introduced the C100, the ECM100U for unidirectional or cardioid, the ECM100N for non-directional or omni pencil mics. And all three of these mics went out or go out to 50K frequency response. There's a lot of information in a lot of instruments that does go out that high. But you don't just use these microphones if you're recording in high res at 96K or 192 or DSD, direct stream digital. If you're just recording at 48K 24-bit, these are exceptionally sensitive and fast microphones that sound lovely. One of the unique capabilities working for Sony and for Sony in this situation is that we're not just a microphone design company. We have an entire record division, Sony Music, that has hundreds of music recording engineers, and our design engineers worked with our mixing engineers, and they collaborated and went back and forth, deciding on the best diaphragm materials, deposition materials, what sounded the best on a whole host of kinds of sources and instruments. They decided to come up with a diaphragm material that imparted the least effect on a sound. We wanted to keep a sound as pure as possible. The deposition material in the diaphragms, which are all made in clean rooms, by the way, is the golden, the same of the C800G. We tested 8 different types of diaphragm materials as well before we decided on what to do. The C100 side address studio mic has double diaphragms. So the large diaphragm covers the frequency range of 20 hertz to 25K. And then the small diaphragm goes from 25K out to 50K. But we didn't want a crossover network like you might expect, because that could hurt the audio. So we designed the backplate of the large diaphragm that would naturally roll off that diaphragm sensitivity at 25K, at which point the small diaphragm kicked in. We take, by the way, that small diaphragm and we put it in the pencil mics only, but we run them full range from 20 hertz all the way up to 50K. Why a wide frequency response? You know, I tell people these mics go out to 50K. They go, what? I'm not a bat, I'm not a dog, I can't hear that. You know, I'm getting old, I can't even hear that anymore. Why do I need this? Well, there's a few answers. One of the straight ahead answers is mics that in the pro world spec'd from 20 hertz to 20K, they don't really go flat out to 20K. They start rolling off at about 12, many of them. And there's a lot of information in a lot of sources, like off of a piano, you know, soundboard that is well beyond, you know, 12 and 13K. So we wanted to be able to capture that, you know, kind of in a true sense. But having high frequency and a sense of temporal resolution, I like to say, gives us a sense of real time, of real spaces. It just sounds accurate to us, and it sounds more like real sound. Here is a plot that was recorded and shown by an Australian pro audio magazine back in 2018, I think, where they were recording a piano with a Bloomline pair of microphones, and this is what they got out of a pair of KM84s. Look at how they dip down, because the mic's just not sensitive up, you know, past 12, 13, 14K. But our mic that goes really nicely out almost to 50K, we captured all that detail that the piano had to offer. So why leave that frequency lying on the floor, sitting in the sound of the soundboard of the piano? These microphones also have that same dual metallic anti-vibration design. However, we've just introduced a new microphone into the family. It's called the C80. It's the little brother of the famed C800G microphone. It was designed to have a sound signature almost identical, but at a far, far lower price range of $499. Again, same diaphragm material as in the C800G. It's cardioid, it's 20 to 20K, low cut filter, 10 dB pad. Lovely sounding microphone, very, very quiet. And over at our demo station over here, you can listen to an 800G and then go over to the C80, and you tell me if you hear any major difference between the two. All right, into our last topic, which is headphones. Many of you will likely know that we have been making for years a very successful product for Sony, an MDR 7506. These are very comfortable headphones. They fold up. They feel like a worn pair of jeans when you wear them for long periods of time. And they sound really nice. However, we just introduced and are showing them all over the booth here, our new open back headphone designs called the MDR MV1. These headphones are an open back design versus the 7506, which is a closed back design. They have an exceptionally wide frequency response of 5 hertz all the way out to 80K, really wide. And they have a carefully tuned open back acoustic structure, because open back headphones have been historically known for not really having a lot of warmth and low end, because a lot of that sound leaks out. Our engineers solve that problem beautifully, but you won't believe me until you actually come over and listen to some. We've got the headphones hooked up to some lovely little high-end digital Walkmans over here, and you can play back some great tracks. We also wanted to make these headphones incredibly lightweight, because you have to wear them for like 10, 12 hours a day sometimes, and you don't want to be conscious of the fact that I'm wearing headphones all day, because that's just a bummer. We made very high-end cables, and we had to completely redesign the diaphragm structure, which we'll go into now. The idea is, why do we make these headphones? Well, first of all, most of you realize that movies have used, immersive sound for years. There are speakers up all over the tops of movie theaters and all around you. And it's only in recent times that the music, our world, has go, how about immersive sound for music? That would be really great. So now we have obviously Dolby Atmos, and we have Sony 360 reality audio. By the way, Atmos is like being in the top half of a sphere, 180-degree bubble over the top of you, and you can have sounds anywhere there. Sony's 360 reality audio, on the other hand, puts you at the center of the inside of a sphere. So you can have sound up in front and behind, but you can also have sounds down below you and behind you down below. So it's almost double the space in which to put elements and sources and stems and things like that. It's really quite wonderful. However, a few years ago, Sony Pictures out in Culver City, California, said, in the final stages of mixing a movie, you have to go into a giant movie theater that's set up for mixing the final stages, and where the mixers can take elements and put them up on the speakers in real live position. And they only had a couple of these giant rooms, the Cary Grant Theater, and I forget the name of the other one, but they reached out to our R&D departments in Japan and said, any way you could make it so that a mixing engineer could put on a pair of headphones and have it sound identical to what they hear in that room? Wouldn't that be something? And of course, our R&D engineers, being who they are, go, we will study. And they came up with an incredible new technology called 360 VME, Virtual Mixing Environment. And that's what we're demonstrating in this room here. What it really means is that you can go into any mixing environment, any size room, any configuration of speakers, mono, stereo, 5.1, 7.1, Atmos, Sony 360 RA, and we will measure you as the mixer, as the engineer, precisely how you hear. We take tiny microphones, put one in each ear, and you sit in the sweet spot, and then we will play sweep tones and pink noise out of each speaker in the room in sequence, whether they're up there, down below you, around you, whatever. And the system will measure exactly how you hear, reflecting the shape of your head, the shape of your ear structure, the reflection off your shoulders, all of those kind of things. And it will create a profile based on not only you, but that room's acoustics and the monitors and the headphones that you're mixing in. And what you leave with is a profile that you can then take with you and put in your laptop and sit in your bedroom and mix through the headphones and have it sound like you're in any of your favorite studios, assuming you were profiled in that room. It's kind of amazing. And so if you sign up and there's times available, you can get profiled here and leave with a little USB stick of a 5.1 mixing environment that you can then take for 3 months and test it out. But it's amazing because they will test you, they will play the sound out of the speakers, then they put the headphones on with the mic still in there, and that cancels out the effect of the headphones, and then they will play the tones out of the speakers again, and you go, yeah, so what, I already heard that. And then the light bulb goes off in your head, wait, I'm still wearing headphones. And you pull them off, and it's quiet. And when the headphones are on, you swear the sound is coming out of that speaker, out of that speaker, out of that speaker. It's a freak. It's a freak out. It's uncanny, and it's hard to be believed. So, this is exactly what you would do. Now, more specifically about the headphones, which were designed to best be used in this situation. You can use any headphone, but the MDR MV1s really are great at making this system shine. Again, we designed them as an open back headphone because if you think like a regular headphone, it's got a closed cup housing and the sound reflects around inside of it and it can cause standing resonances and things like that, which can hurt and smear the localization cues of position. So we wanted an open back headphone. But open back headphones historically have the trouble that I mentioned earlier, which is like low frequency and things like that. So we had to eliminate the resonances, and we wanted to have this very wide frequency response, again, from 5 hertz all the way up to 80K. In order to do this, though, we had to completely redesign the diaphragm of the headphone speaker. If you consider that that diaphragm now has to be able to reproduce from 5 hertz all the way up to 80K and do it smoothly in a smooth transition way without a bunch of dips and hills and valleys, huge challenge. First of all, the center of the diaphragm has to be stiff enough to be able to do 80K, but the edges have to be pliable enough in order to do down as low as 5 hertz. But the problem in traditional diaphragm designs is they usually have these what are called corrugated lines, and they just run radially right from the center right out. But when you crank up the volume on a headphone, the low frequency can start distorting easily, and our engineers wanted to solve that problem. So what they did is they came up with something called curved corrugation, where they made those corrugated lines now curved, and that cut down on the distortion a whole lot, and that was wonderful. So we got that solved. Now the other problem is your low frequency, you don't want it, you want it to be there, but you want it to be tight. You don't want a mushy low frequency. We have it there, which is, you know, a good thing to do in, you know, an open back headphone, but we needed it to be tight. So they came up with something called a tri-duct structure. And you can see that in this picture here. You see those 3 little posts. You can see that they're a very specific height, width, size, and there are little holes drilled in them of a very specific size. They act as acoustic resistors, and they let a certain airflow at a certain frequency range through. And so that is the way of tuning. It's kind of like a port of tuning the low frequency to remain very, very tight. Now, what would a pair of Sony headphones be if they weren't insanely comfortable? So what we did is we first changed the head pad material, the ear pad material. And we also, realizing that these headphones were being used for immersive mixing, the position of a sound source was critical. You needed to be able to take the headphones off, put them back on, and the sound source is in the exact same position. This material is the suede-like material, which is the same that gets used in luxury sports car seats. Because if you figure you're driving your $300,000 whatever's car and you're going around a hairpin turn, you don't want to be sliding out of your seat. So there's got to be a certain amount of grab, which is lovely, but you don't want it to be, you know, it's got to be able to breathe for headphones and all those things. So that's what we used here. These headphones, though, when you come and pick them up, you'll go, man, these things are crazy light. What is so light about them? Initially, I thought they were all made of plastic. I go, yeesh, but they're not plastic. These headphones have had every component in them reduced in 1/10 of a gram increments until a part no longer became structurally strong enough to be considered for professional use. So we were able to reduce the weight, but the material of the ear cup is not plastic. That is an aluminum alloy, and we had to find a way to drill all of those little holes individually and cut those slits individually. So very strong as a professional headphone needs to be, but crazy lightweight, and you can wear them again for many hours a day. The headphone pads are easily replaceable by a customer. They even went off on the cable. It's no longer a coiled cable like the 7506. It gets all kinked and it bums you out. We have knurled machined aluminum connectors. We provide a locking connector into the headphone so it doesn't pop out on you, but you can change that if it ever gets rolled over by your chair or whatever. We have a little 1/4 inch down to mini jack connector so you can drive these from your cell phone. And these headphones have just 24 ohm operation, so you can crank them up even off of a cell phone. Here is some of the fine tuning. We also have our high-end mastering studio in New York City called Battery Studios. And we brought the engineers from Battery Sound in to help us voice the headphones so that they sound as close to speakers as possible. And that was really important for the 360 virtual mixing environment. You wanted it to sound really identical. So here the engineer pulls them apart after getting a little, bit of advice from the mix engineer. It needs a little more here, a little more there, and he makes it happen. So here's the final spec. And we'll close by just saying that in my 40 years with Sony Pro Audio, I've seen a lot of very professional tools and technologies coming from Sony. And these MDR MV1s absolutely rise to the standard of being an incredible Sony professional headphone. Thank you very much for your time. Appreciate it. Have a great show.